moving back towards percentages, and these are fractions. Look, each of these problems, even 7.3 and 7.4, you had a relationship in a fraction, part over a whole, and then you had two parts equaling a whole. Even when we had 7.4, those were two parts equaling a whole, and we are going to sort of utilize that. So in these percent change problems, we have two steps to this. We're going to have, step one is find the amount of change. We have to see how much is it changing. Is it increasing? Is it decreasing? So the amount of change is going to equal the new amount minus the original amount. So in this example, let's take this one, the price of salad bar from 3 to 3.45. This is going to be a stinker of one because there's decimals and stuff like that, but it's the new. So the new value is 3.45 and the original is going to be $3. So my amount of change, excuse me, I should have written amount of change. My amount of change is going to equal 0.45. And it changed by 45 cents. It increased 45 cents. That's finding my amount of change. So that's the first value you need to do. Second part is, now we're going to find the percentage of change. And the percent of change, I just write this, percent of change equals the amount of change over the original amount. I don't know how you have to spell original amount, or the original value. So percentage of change in this example, the amount of change was 0.5. The original was $3. So what is that as a percent? Well, we're in fraction, so we have to convert it to decimal. So we can either use a calculator and do 0.45 divided by 3, which gives us 0.15. So percentage of change as a decimal is, what I say, 0.15. And now I'm going to change this to a percent. So this is fraction to decimal. And now I'm going to change it to a percent by 15% is now a percent. And because it's positive, it's 15% increase. So I don't know if they ask for increase or decrease, but that's how we're going to do it. If you end up with a positive value, it's increase. If you end up with a negative value, it's going to be decrease. And you'll see something when we do. All right, so number one is find the amount of change, which is the new minus the original, which is 2. Now the percentage of change is going to equal the amount of change over the original, which equals 1/10, which equals 0.1, which equals a percent of increase. So that was a 10% increase. It's easy as that. Find the amount of change, which is the new minus the original, which equals 12. The percentage of change is going to equal the amount of change over the original. And look, we can just, if we have a calculator, 12 divided by 48 is 1/4 or 0.25. So I know that that's equal to 0.25, which is equal to 25% increase. Okay, my value increased. It went from 48 to 60, and it increased by 25%. Amount of change is new minus original, which is 4%. Of change equals 4 over the original, which is 1/8, which equals 0.125, which equals 12.5% increase. These are fractions that you should know their decimal values. You should know that 1/8 is equal to 0.125. And then convert the decimal to a percent. Amount of change is new minus original, which is 1%. Of change equals the amount of change over the original, which is 0.25, which equals 25% increase. Oh, I like this. This is where it gets fun. Okay, so amount of change equals the new minus the original. Okay, so that's my amount of change, and then my percentage of change equals the amount of change, which is x minus 40, over the original, which is 40. And we know what the percentage of increase is. It's 5%. Now, we can't deal with percentages, so we're going to have to take this. We cannot cancel those 40s because it's being added and subtracted. We have to convert this to a decimal. Convert from a percent to a decimal. So decimal is 0.05. Remember, we moved the decimal point 1, 2 places, and 1, 2. And now, if we want, we can do a couple things. I'll show you one technique here. So now we have a variable that's being added and subtracted and multiplied. I'm going to get rid of the things. I'm going to multiply it by 40, and we get x minus 40 equals 0.5 times 40. 5 times 40 is 20. I got one decimal that way. I got one, so it should be 2. Yeah, I think it's 2. 40 times 0.05 is 2. Good. Now we're going to add 40, and we get x equals 42. So x represented my new, so my new price is $42. Does that make sense? Yeah, it increased 5%, so it's going to be more than my original, and that would give me 42. That's how I would do it. So amount of change equals the new minus the original. Oh, original, and then percentage of change equals the amount of change over the original, and that equals the percent of increase, which is 60%. So we're going to convert the 60% to a decimal, which is 0.6. We're going to multiply both sides by 0.25, and that gives me x minus 0.25 equals, if I had 6 quarters, that's going to give me $1.50, and I think that's 1.5, might be. I don't know. No, it's probably going to be smaller. It's probably going to be 0.15, 0.15, maybe. Let's use a calculator. 0.6 times 0.25. Yeah, 15, 0.5. Now we're going to add 0.25, add 0.25, and we get x equals, and so we need to write it in currency. So the original price was 40 cents, or the new price is 40 cents. Yeah, we increased 25 cents by 60%. We get 40 cents. It's kind of fun. Now, hopefully you're seeing how easy this is. Amount of change equals the new minus the original. Percentage of change equals the amount of change over the original. And my percent of increase is 20%, so 0.2. We're going to multiply both sides by 80 to isolate the variable. We get x minus 80 equals 160, 16? I think it's 16. One decimal. That's 2 times 8 is 16, yeah. Add 80, and we get 96. X equals 96, so $96 is the new amount, 20%. So there's some other fun, interesting, oh good, all right, original price. So here, now we change it. Amount of change equals the new minus the original. So our percentage of change equals the amount of change over the original. Another variable equals 25%, so 0.25. We're still going to multiply both sides by x because I got to get rid of that variable in the denominator. So that cancels. You're left with 15 minus x equals 0.25x. Now we're going to move the variable over. We get 15 equals 1.25x. Make sure you know how to add whole numbers and decimals. Then we're going to divide by 1.25, divide by 1.25. And yes, I could think about it and move things around, but I'm just going to use the calculator. And we get 12. 12 equals x. So $12 is my original amount. Does it make sense? 12 to 15 isn't, yeah, it's an increase. Amount of change equals the new minus the original. Percentage of change equals the amount of change over the original. Oh, look at you, 0.3 repeating. Oh, did you know that? That's the decimal. Now, that we'll get there. So that we come, well, you'll see. So we multiply by x. Multiply by x. We get 14 minus x equals 0.3 repeating x. Well, that doesn't really help us because when we add this x over, we're going to get 14 equals 1.3 repeating x. Now, what are we going to do? Divide? No. So we got to understand that that's 1 1/3 x, which equals 4/3 x. And now we can multiply by the reciprocal. So that's where it becomes beneficial. And you could have converted it back up here, where 0.3 is 1/3. 1/3 is equal to 33 1/3%. You should know that at this point. We get 3 times 21 over 2 equals x, which is 10.5, or equals x, which means it's $10.50 was the original price. Increase that by 1/3, and we get that value. All right, original price, we're still percent of increase. Wait until we go decrease. That's where it gets interesting. So amount of change equals the new, new minus the original, right? New minus original. Did I do that? New minus original. Yeah, okay, this is good, yeah. Percentage of change equals the amount of change minus the original equals a 5%. We're going to multiply both sides by x. That gives us 168 minus x equals 0.05x. We're going to add x to both sides. we get 168 equals 1.05x divided by 1.05. And I have no idea. 168 divided by 1.05, 160. Ooh. So $160 is my original amount. And notice 1.05, that's 105%. And think about it. If we increase by 5%, what's my new value is, right? If this is 100% of the value of the original, my new price is going to be 105%. So understand what those values mean. So that's good. You'll see that in balances, compound interest problems. Those are good. All right. So now we're going to decrease. So it's still amount of change equals the new minus the original, which gives us a negative value, negative 1.5. And we can still do this. Percentage of change equals the amount of change, negative 1.5, over the original. And this is, you saw in the beginning, they give you two different problems. One for percentage increase and one for percent of decrease. And you shouldn't have to. It's the same. See, they do it this way and then they change it up. Don't do that. Just understand what you're getting. Do the same one and just, right, see, they've changed it now. No, don't do that. Just understand what the negative means. Negative means it's a percent decrease. So here we have a percentage, so we're going to do 1.5 divided by 6, which gives us 0.25. So negative 0.25. Now, the reason you have to understand that it ends up 225%, but the negative is represented in the word decrease. You would never have a negative percent. We say either increase or decrease. The decrease represents the negative. The increase represents the positive. So amount of change equals the new minus the original, which gives us negative 4, sorry. And our percentage of change equals negative 4 over the original, which equals negative 1/8, which equals negative 0.125, which equals 12.5% decrease. No calculators, still no calculators. Amount of change equals the new minus the original, which is negative 9. Percent of change equals negative 9 over the original, which is negative 3 goes into that. 3 goes into that. 3 times 3 goes into that. 20. I don't know what that equals, but it's going to be some fun number repeating. Oh. What? No. Did I? 3? 3 goes into 12. What happened to there? 9 divided by 60. Okay. Negative 0.15. That is so weird. What? No. Am I doing this right? I feel like I'm doing it. 9 divided by 60. I did something wrong. 3 divided by 20. Huh. That's blowing my mind. I don't know why I can't see that. So this is 15% decrease. That's, 20 into 3. I kept dividing 3 into 20. Sorry, that's the problem. 20 definitely goes into 3, borrowing a couple times, or moving decimal places. Sorry. Amount of change equals new minus original, which equals negative 1.5. percentage of change equals negative 1.5 over the original, which equals negative 15 over 75. 5 goes in that, negative 3, and 5 goes into that, 15, okay, which equals negative 1 and fifth, which is negative 0.2, which equals 20% decrease. Pretty sure that's good. It's a 20% decrease. Amount of change is where it gets fun. Change equals new minus original. Percentage of change equals new amount of change over original. And then here's where it gets interesting. This is where you have to represent the negative 0.3. So when you have a percent of decrease, that has to be a negative value here. So we'll still multiply by 80. We'll still multiply this by 80. And we get x minus 80 equals, however, this is going to be negative 24. And that's where you're going to see the difference. So now these signs are going to be different before in the other one. So that's 80, 24, which is 56. 5, 6, 7, yep. 56. So the original amount was $56. Notice my original amount, or my new price, is not a negative value, but it is a smaller value than the original because we're decreasing it by 30%. So the new value is 56%. So that's where we understand what these words mean. Original price, new price, percent of decrease. We're decreasing it by 25%. You can find 25% of that and then subtract it to create. That's just, yeah, you could do that. But I think that this is pretty good. This is your traditional percent amount of change is going to be new minus original. Percentage of change equals the amount of change over the original equals negative 0.25. Let's multiply both sides by 2. And we get x minus 2 equals negative 0.5. Let's add 2 to it. And we get x equals 1.5, or my new amount is $1.50. If we decrease $2 by 25%, do we get $1.50? Yes, we do. Now, amount of change equals new minus original. Percentage of change equals the amount of change over the original, and we're decreasing by 20%. Let's multiply both sides by 6. Multiply by 6. We get x minus 6 equals negative 1.2. That's good. Add 6, add 6. We get x equals 4.8. So my new value, if I decrease by 20%, is $4.80. Notice where the dollar signs go. Amount of change, now we're going to change it up a little bit, equals the new minus the original. Percentage of change equals the amount of change over the original, and 12.5 negative 0.125 is 12%, 12.5% as a decimal value. We're going to multiply both sides by x. Multiply both sides by x. We get 210 minus x equals negative 0.125x. Let's add x to both sides. Add 1x. We get 210 equals, this is going to be positive 0.8 0.875x. Yeah, I think that's right. Neat. Yeah. Now we're going to divide both sides by 0.875. 210, I don't know what this is, 210 divided by 0.875, which gives us $240. 240 equals X. So my original amount, if I started with 240 and decrease it by 12.5, do I get a smaller value of 210? Yes, that seems very reasonable. It's in the ballpark. Amount of change, how many more? Not too many more. Amount of change equals new minus original. Percent of change equals the amount of change over the original, which equals negative 0.2%. Or decimal, we're going to multiply both sides by x. Gets rid of that variable in the denominator. It leaves me with 4 minus x over negative 0.2x. Let's add x to both sides. We get 4 equals 0.8x divided by 0.8. And 4 divided by 0.8 equals 5. 5 equals x, so my original amount is $5. Makes sense? $5 decreased by 20% gives me $4. Last one, here we go. Amount of change. New minus original. Percentage of change equals the amount of change over the original equals my percent decrease. Since it's decrease, it's going to be negative percent decimal. We're going to multiply both sides by x. 136 minus x equals negative 0.15x. Add x, add x. 136 equals 0.85x. Divide by 0.85. 0.85. Using our calculator. Yes, we'll use the calculator on this. 115.6. 115.6 equals x, which means equates to $115.60. Write the cents, add that 0 in there, and if we decrease... No, I made a mistake. So this is why we check. This is why we check. So that value, I think I multiplied incorrectly or divided incorrectly. We should get more than the 115. So here's why we check. I can't have $115.60, decrease it by 15% and get a bigger number. That doesn't make sense. That's not a reasonable answer. So let's go back and do that calculator. As I told you that the calculator, 136 divided by 0.85 should be a number larger than 136. 160. Silly. So $160. Now, going up here, 160 original, decrease 136. That makes a reasonable answer. So, made a mistake on the last problem, and which was timely because it showed us why it's in our best interest to at least check, is the answer reasonable? Yes, it was in this case. Good luck.